So for those of you that just joined us, my name is Danail and Dimitrov. I'm a cloud solutions specialist at Grey Matter Limited, actually cloud and infrastructure solutions specialist at Grey Matter Limited. And this particular session is about data. So we're going to be talking a lot about SQL, because relational databases, like it or not, is at the heart of the majority of the businesses out there. Majority of the ISVs around this room will also incorporate relational databases, SQL Server being one of the more popular choices out there and being a logical choice for anybody that's adopting Microsoft technologies. What we're then going to talk about is platform services in this particular session. We'll briefly touch on storage and we'll briefly touch on identity. So I'm hoping to show you how to utilize all of that storage in a secure fashion, so you're not having to hand out details left, right, and center. So I'll refer to a diagram I'm referring to throughout all of the sessions I'm delivering today, which is the balance of responsibility. I'm not going to take up too much time, but basically with the balance of responsibility, we acknowledge how much we're responsible to take care of and how much the platform provider is responsible for, in this particular case, Microsoft or Microsoft Technologies. So when we look at a traditional implementation, we have to worry about everything networking up. When we're adopting infrastructure services, we're literally looking at the operating system, and above is our responsibility. So Microsoft actually manage the hypervisors, they manage the virtual machines. We only need to manage the operating system on top of that, managing all of the Windows updates, and then everything else that's configured on top of the particular operating system. And we're actually going to talk a lot about platform services in this particular session. So we're going to see what platform services are currently available for us on the Azure platform, because realistically this is where we want to be. This is where we can achieve a cost saving in delivering those services to our customers over platform services. That's where we want to be. So without any further ado, let's talk about Azure SQL Database. Can I get a show of hands as to which ones of you here are aware of Azure SQL Database? Okay, so I'm teaching grammar to suck eggs here, so do bear with me. It's in the interest of the majority that everybody knows exactly what these services are. So with Azure SQL Database, I'm not sure how many of you are aware, it actually learns and adapts. So with Azure SQL Database, it's able to monitor our performance, look at those long-lasting queries that are taking a lot of time to execute, look at those queries that could potentially be improved upon through indexing, and it actually automatically indexes out of the box for us. Now, Azure SQL Database scales on the fly. What that means is we've got two ways of scaling. So if our demand peaks at certain times of the day, say we experience demand between 7 o'clock in the morning and 5 o'clock in the afternoon, what we can do is we can preemptively scale up based on a schedule. So we can be very proactive, but we can also be very reactive. So if our traffic or demand does not have any particular pattern to it, it peaks at different times of the day, then what we can actually do is we can monitor metrics on the platform. We can see how much it is that we're consuming, and we can scale based on all of that. It also has minimal downtime in scaling. So what we can do is, when we scale up, what the platform essentially does is it spins up a new instance of our database with the new resources that we've defined. What it then does is it copies the database across, it mirrors, and once both of those databases are in sync, it actually then switches all of our connections so they point to the new version, and it decommissions the old server. So it actually scales up and scales down in a very seamless fashion. The only thing that may potentially be impacted is if you've got long-standing queries, something that's taken an hour to execute happens to be executing at the time you want to scale up, then that's pretty much inevitable. Azure SQL works in our environment because it's based on exactly the same engine as SQL Server. So the same engine that's used for Azure SQL is actually what then goes into our fully fledged versions of SQL Server when those are deployed as a standard SQL Server installation to our customers. So it actually uses the same engine. What that means is that we can then use the same tools to integrate with it. So we can use SQL Server Management Services, Management Studio, to manage our Azure SQL Database servers. And what we can do is we can also use things like Visual Studio, other tools which we're already using in our environment. Now, of course, security is at the heart of any platform service, and actually any service in the Azure platform. So what we've got is we've got encryption at rest. And we've got high availability. So any platform service is natively 99.99% has got availability. And is with Azure SQL Database, we've actually got up to 35 days backups natively with the platform with any point in time restores. So if we want to restore from 9 o'clock this morning, we could do that based on the tier that we're using for our Azure SQL database, and that will change, and we'll talk about that later. So with Azure SQL Database, we've got two different ways of purchasing that particular service. So what we've got at the top is we've got data transact units, and this is a depiction of what a data transact unit looks like. So data transact units are a unit of measurement introduced by Microsoft for Azure SQL databases. It came when they were first defined, and basically it's a combination metric. It looks at CPU performance, it looks at memory, and it looks at disk write and read operations, and it basically generates this combined unit of measurement. So all of these are then they've got a ratio between one another, so that ratio doesn't change as you provision more and more DTUs. It's all consistently the same. Now with the DTU model, it's got three different tiers. It comes in basic tier, standard tier, and premium tiers, and those have a few obvious differences that we'll talk about a little bit later. Now the DTU model is very quick and easy for us to adopt because the DTU tier start at 5 DTUs. So the basic tier, you're really provisioning very little resource. I think it costs you about $3 a month to provision a very small database with Azure SQL databases. So it's very cheap for us to start off with that. But we do not get a choice of how many cores we provision. So unless we're using a standard S3 or above, we're not actually provisioning more than one core. So we cannot do or process transactions simultaneously at the same time because we've only got one core available to us, and that's actually a logical thread as well. And we do not really get granular control over storage. The storage that we can provision directly correlates to the pricing tier we're using, and it also depends on the size of the database that we've got. So that is quite a limited option for us with the DTU model. And now, more newly than that, what we've introduced is the vCore model. So the vCore model comes in two flavors. We've got Generation 4 and Generation 5. Generation 4 and Generation 5 having an obvious difference of the maximum virtual cores you can provision, and also the correlation between CPU and RAM. So with Generation 4, what you get is 1:7 ratio. So for each one virtual core you provision with the Generation 4 model, you get 7 gigabytes of RAM. With the Generation 5, you get 1 to 5.1 correlation. So for each one virtual core you provision, you get 5.1 gigs of RAM. So that's the obvious difference between both of them. But what you do get with the vCore model is you get completely independent storage. So you can control that regardless of whether you choose Gen 4 or Gen 5, and we'll show you what that looks like in a bit as well. And of course you get to choose the number of cores you've got. That's the whole idea of the vCore model. So if you needed to have 2 or 4 cores, you needed to simultaneously process a number of transactions, then you've got that granular control over how many virtual cores you have provisioned in your environment. So looking at the DTU model, I specified that there's 3 different tiers, basic, standard, and premium. There are a few differences to note between these. So maximum storage being an obvious one. With the basic tier, you only get 2 gigabytes of storage, and that changes to 1 in the standard and 4 terabytes on the premium storage. The type of storage also changes. So premium tier is based on SSD storage, whereas the standard and the basic tiers are based on conventional hard drives. So the performance you're going to get out of a premium tier is going to far outweigh the performance you're going to get out of standard and basic, especially if you have bigger transactions that are being processed. And of course, the backup retention. So with the basic tier, those any point in time restores, they're only covered for up to 7 days with the basic tier, and you get 35 days with standard and the premium pricing tiers in there. The same applies to the vCore model. Pretty sure this does not capture everything. With the vCore model. So we've got Gen 4 and Gen 5. I said obvious differences there being the amount of virtual cores you can provision. Storage is exactly the same. But then if you go into business critical tiers, your storage will change to 1 terabyte for Gen 4, 4 terabytes for Gen 5, and you've then got Hyperscale, which we'll quickly cover in a second as well. You get 35 days retention across the board, but what drastically changes is also the disk performance as you go up through the different tiers with the vCore model that's now available to us. So Hyperscale. Now in the conventional database, hosted database, the same nodes that basically are going to process your transactions, those have local storage tied to them, and that is abstracted away in Hyperscale, which is currently in preview. So what we've done I say we, what Microsoft have done is they've introduced this hyperscale notion where the storage is completely abstracted away from the nodes that are then executing your transactions. And they actually reside in storage similar to a storage account, like blob storage. That allows us to then achieve greater scaling. So with that, we now have a limit of 100 terabytes of storage per single database, which is far greater than the 4 terabytes we've had available to us up until now. We can back up and restore a lot quicker because our backup and restore is unimpacted by live transactions. It's not impacted by the current demand on the computing resource that we have available to us and provisioned. And of course, that works vice versa. So our I/O impact on the compute resources is unimpacted by the backup and restore operations that are being done. We can achieve higher log throughput and faster transaction commits, so we can achieve greater and quicker overall performance with Hyperscale, and we can also scale out and scale up a lot quicker. Up until now, our ability to scale out and scale up has been influenced by the amount of storage provisioned on the database, because that storage has been tied in with the compute resource that we're scaling out and scaling up. So we would have had to copy the full 4 terabytes of storage across to be able to provision a new instance for you, to actually introduce more replicas, or to scale up your resource. So that would have taken longer the bigger our database has got. Because we've abstracted the storage away, we can now scale up, scale out, scale back in a lot quicker, and we remain unimpacted by the size of the database that we have provisioned. So let's have a look at how easy it is for us to provision a new Azure SQL database. So this is going to be a very quick demo for those of you that are not aware, because I am familiar that most of you have already provisioned an Azure SQL database. So for us to provision a brand new resource, what we do is we go to the plus in the top left hand corner and we click on type in SQL database, which is already available for us. With a SQL database, and we've already covered that connectivity has not been our forte today. Just make sure we're still connected. There we go. What I'm going to do is I'm going to define a new name for my database. So I'll call it event ISV data. And what I'm going to do is choose a server that this database is going to reside on. So the server is not really a physical server, it's just a way of grouping resources together. In reality, these databases are going to be hosted across a number of different nodes. They're not going to be hosted across one node. So if I call this again event ISV data, that's currently available, and I get to define a username and a very secure password, which we've already covered, in my West Europe region. And it's really as simple as that. I now get to choose whether I want to provision this in an elastic pool, but we'll talk about that in a second. And I get to choose what pricing model I want to use. So I can use my DTU model, the 3 standard tiers, the basic, standard and premium, or I can go with the vCore model. And if I just go to the vCore model very quickly to show you what one core costs me, one core with 32 gig database in general purpose costs me 152 quid. If I revert back to the DTU model and I start a very basic database, we're talking something a lot cheaper there. So for me to start off with this, it's a lot easier. And at any point I can change from one to the other if I wanted to. So I will apply this, go additional settings. I'm not going to change the rest of this. I'm just going to create the resource because we've already done the introduction to Azure earlier on in this particular path. And what that'll do is that'll provision that new SQL server, and it'll provision the SQL database on top of that for me to connect to. But we're not going to wait for that to process, because it could take, from past experience, up to 3 or 4 minutes for the server to provision with the database on top of that. And we'll dive straight back into the presentation. So that's all well and good. That's not supposed to happen. That's all well and good if we want to provision resources on a case-by-case basis. So we want there we go. That's all good if we want to provision resources on a case-by-case basis. But what happens if we've got 10 customers? Those 10 customers are all based in the same geographical location, so they're based in the same country, i.e. their hours of operation is the same, it's all at the same time, but their demand peaks and troughs at different intervals because they're choosing to process at different times. Are we realistically going to provision 10, 100, 500 DTUs per customer? In that particular scenario, it makes a lot of sense for us to look at SQL Elastic Pools. So SQL Elastic Pools allows us to provision a joint pool of resources that multiple databases can then utilize. And it allows us to cater for these peaks and troughs. Of course, Elastic DTUs and Elastic Pools are a little bit more expensive than provisioning resources individually. But if we can monitor and provision them in the right way, what we can then do is achieve a very good cost saving. So we can then accommodate these particular peaks and troughs, but we can do so whilst achieving a particular cost saving across all of our customers. So just to demonstrate how easy it is to now provision an Elastic Pool in the particular database server we've just created. So we've got this server here, event ISV data. And what I need to do is just click on new pool at the top. In here, I get to define the pool, and I'll call it pool. And I get to define the number of resources. So Elastic Pools support both the DTU model and the vCore model. So if I wanted to, I could provision vCores. I'm just going to provision box standard 50 DTUs. And I'll create a new Elastic Pool on that particular server that I can then put any of the databases on the server into or out of. So I can move databases into an Elastic Pool, and I can take them back out as many times as I want to. I'm not restricted in any way, shape or form, but of course the underlying resource will change as I do that. So in this particular case, this Elastic Pool is taking a little bit of time to provision. I'll give it another 10 seconds or so, and if it doesn't provision, we'll just use an example we've already created for us. There we go. So we've got the Elastic Pool shown up in the background here, and if we click on that, we get to see the information for this particular Elastic Pool. If it's loaded, and if we go into the configuration, what we can now configure is the same resource here, so we can change the resources in our Elastic Pool. But what we can also do is we can now change the databases that reside within that Elastic Pool. So if I wasn't to provision a new database and I wanted to just move an existing database into that particular Elastic Pool, then what I could do is I could select the database, apply that, save the change. And that database is no longer being billed separately for those basic 5 DTUs of £3 a month. That's now being billed at £83 a month is what I've done there. But in an ideal case scenario, you'd group this with other databases, and again, you would be able to achieve that cost saving. So that will only take a couple of seconds to apply across, and that database should now show up in here. We just refresh. I think we did this a little too quickly after the provision of the Elastic Pool. So yeah, it will take a bit of time for that to reflect in there, but it's pretty seamless usually. Now we can group those databases together. So we've taken care of the cost factor, we've achieved the saving, we've already adopted platform services, we're sharing resources between those platform services out there. But what happens when you try and achieve greater functionality? So we've already covered that Azure SQL is based on the same SQL engine as a conventional SQL server. So we already know that it can perform all of the latest different types of transactions, but what it cannot do is it cannot do cross-database transactions. If you try to reference a different database server in your join, open row set queries, any join queries, what you end up getting is an error message very similar to this, but except it'll be in red and it'll look very bad and daunting. And what that'll basically tell you is that this convention is not supported in the version of SQL Server you're using. So I cannot define a database before my DBO, the customer table, in there. So we cannot actually do that. There is a few ways to go about it, which we'll talk about in a little bit of time. Now, other functionality that's not supported in Azure SQL Database is SSIS. So SQL Server Integration Services is not supported. SQL Server Reporting Services is not supported. And SQL Server Analysis Services is also not supported on the Azure SQL databases. In addition to that, we don't have a SQL Server agent. So those of you that have jobs running in the background to periodically move data, those of you that have jobs in the background to periodically cleanse that data, you cannot do that with SQL Server Agent because one is simply not available to us on that particular platform offering. But we still want to adopt this particular platform offering because we can achieve a cost saving and we can scale very quickly. So we can meet demand. There's no upfront commitment for us. We're not paying for SQL Server licensing based on virtual cores that we have provisioned on our SQL Server. So we want to adopt this wherever possible. Now, how can we overcome some of these problems? Well, we've got a lot of offerings on the Azure platform to help us overcome these different problems. So if we want to look at how we can integrate more seamlessly with databases without the support for cross-database queries, then what we've got, if I go back, press the wrong button, is we've got elastic queries. So if our data is sharded across multiple databases, but all of those databases have exactly the same structure, so they've got the same tables in there, they're storing exactly the same data, but for different customers, what we can look to implement is we can implement elastic queries. And elastic queries allows us to query across all of the databases at the same time through one query, so we can gather results from multiple databases and overcome that problem. We can look at elastic job agents, which are currently in preview as well. So those allow us to do a similar thing to elastic queries, but it allows us to schedule those jobs much like we would with a SQL Server agent. So we can overcome that particular problem there. We've also got Azure Functions. So for those of you that would just had to endure my painful demos not less than an hour ago, I demonstrated how we could use Azure Functions to actually call out to an Azure SQL database and update that data. So we can use things like Azure Functions to bring out and collate that data together and modify that data despite not having access to a SQL Server agent. And what we've also got is Data Factory. So Data Factory version 2 allows us to support existing SSIS workloads. So we can actually import SSIS workloads into Data Factory version 2. And Data Factory version 2 comes with out-of-the-box copy data pipeline, which is pre-configured for us. And it allows us to copy data from one database across to another. So we'll show you what that looks like in a bit of time. Now, in terms of reporting, we no longer have analysis services, but what we've got reporting services, but what we've got is we've got Power BI. And Power BI is a lot more flexible than SQL Server reporting services, which is why we're encouraging people to adopt Power BI and look at Power BI. Now, licensing with Power BI is a little niche, so do speak to one of the members of staff from the Grey Matter team who can go over the licensing options with you. And of course, in place of analysis services, SQL Server analysis services, we've got Azure analysis services, which does exactly the same thing as a standalone service. So not everybody is going to need analysis services, but for those people that do, there's already an offering available on the Azure platform to fulfill that requirement in there. So what I want to show you is I want to show you a quick example of Data Factory, because Data Factory is a very, very easy way of copying data across from one database to another. So again, in the interest of time, I've actually configured Data Factory already. Now, Data Factory can take up to maybe 5-10 minutes to provision in our environment. So what I've done is I've provisioned just a box standard empty instance. So in this particular server I've connected to, I'm not going to use this particular example. I'm going to connect to another server. So I've got a server configured in here with a few databases on there. So if I click on the database in there, I can see the server name. I'll copy that and I'll connect to this. But ahead of time, I'm actually going to navigate to the server and enable me to connect to it through the firewall settings. So if I try and connect to this particular server right now, I'll get an error message. It will ask me to add this particular IP address in. I'm just logging in so I can copy the IP address because I'm using a preview version of SQL Server Management Studio, which certainly doesn't seem to like me adding these in through the interface. So I'm going to copy that in there because it's been read slightly differently than the Azure portal. I believe since I connected to the Azure portal, my IP address on my hotspot on my phone's actually changed, which is why this is reporting a different IP address on there. And now that I've done that, I can connect to my server. This particular server has got a few databases provisioned, but more importantly, these databases follow the same hierarchy to make it very easy for me to, same structure, to make it very easy for me to copy data across. So I've got this particular database, which has got data in it. No, it hasn't got data in it, sorry. This is an empty database, and I've got one which is just migrated from on-premise with data in it, with exactly the same layout, just to prove concept. Okay, so addresses in this particular case. Really doesn't like me. Thank you. This particular table has got the same 4 records we would have seen in an earlier demo. So this has got 4 different records in there. What we're going to actually use is we're going to use Data Factory to copy records from this particular database into this particular database. Both these databases are Azure SQL Database, so they cannot transact with one another, but we can overcome this particular problem in using Data Factory. So Data Factory looks like this. There we go, version 2. And I can just click on Author and Monitor to create new, I guess, workflows for moving data and manipulating data in my environment. So we create what is called pipelines, and those pipelines are then triggered by certain events, much like we would in a serverless technology implementation. And once this loads, I've got this copy data predefined pipeline for me. So this is very easy for us to adopt. So I'll call it something very simple. And then I'm going to run this once, and I'll run this now. I can set this to trigger periodically if I needed this to run on a periodical basis. And this service can integrate with so many services out there. So I'm just going to use the Azure platform and create a new connection here, because if I use the All Services platform, there's going to be so many in there. And I'll use Azure SQL Database as my source of data. So this is where I'm going to be copying the data from. Just call it ISV copy from. And this can integrate with Key Vault, but what I'm actually going to do is I'm just going to manually select everything from here. Pick the server that this resides on and pick the database. So we're copying from the migrated database to the copied database. And I'll enter the same credentials I use to connect to it. So we test this, make sure it all works, make sure it's happy. Press finish, and we've got our data source ready for us to select and proceed with. Now I get to choose what I want to copy. So I'll choose both tables in there. 8 records should not take too much time, and I get to choose what I want to copy to. So again, in the same way, I'll use an Azure SQL Database, define ISV copy to, and connect to the new database on the same database server, so copied, which is currently empty. Input my credentials, test, make sure that I've typed that correctly, finish, and select that as my destination. Okay, so this will just read through now, find out what tables I've got defined. It automatically match those up if it can, and I can also see what those columns look like, etc. I'll wait for those to be automatically mapped, so I can change the way that those columns map across if the structure is not exactly the same, so sometimes that's not possible for us. But I wanted this to automatically do everything for me. We get to see how it behaves in the event of a failure and skip through all of that. And now that will trigger that copy for me. So that copy is already triggered, it's in progress. So what, we'll wait for this to see. This will, and it's just succeeded. So it's already run in under 11 seconds. It's copied 8 records across for us by connecting back to what was previously our empty address table. We've got those 4 records in there, copied already. So that is one of the numerous different ways we can look to overcome some of those obstacles and some of those limitations around the more managed services that are available to us on this particular platform. Now, diving back into this, we've got 10 minutes left, and it is my absolute mission not to overrun this again. So aside from that, if Azure SQL Database and all of these offerings are not feasible for us, or they're too much of a jump from where we are at the moment, what we've got available is SQL Managed Instances. So SQL Managed Instances is much like a conventional SQL server, but it's managed for us. Now, SQL Managed Instances still comes, what it does is it comes with near 100% compatibility. So it's nearly 100% compatible with a full SQL server deployed in a virtual machine. It does allow you to do cross-database queries because they technically reside on the same set of resources. So we're now aware of the other databases that run on this particular managed instance. And we can now query across all of these databases. It's still got limits, so it doesn't come with SQL Server integration services. It doesn't come with reporting services or analysis services, but it does actually have a SQL Server agent. Now, that SQL Server agent comes with default configuration. If you wanted to change the configuration, you would have to, again, opt into a full SQL Server instance on a virtual machine. We do not have the means to currently modify the way that this behaves, or at least not by much. And of course, SQL Managed Instances supports the same tools and the same migration tools as well that we can use to migrate from our environment at the present. Now, if that didn't obviously satisfy your requirements, then we've got SQL Server and VMs. And the reason why I'm mentioning this is there's so many of us out there that are still using 2008, and 2008 support runs out very quickly. But what you could do by doing a conventional lift and shift from on-premise onto Azure virtual machines with SQL Server on that is you're entitled to 3 years extended support free of charge. And that extended support will cost you so much more if you were to remain on-premise. So by lifting and shifting our 2008 servers with SQL Server on top of those, we're able to basically buy ourselves more time for us to adopt those newer technologies that are available for us and are more flexible. Now, we've got a number of other options as well. So we've just covered 3 different options before I get too far ahead of myself. So we've got SQL Server on a VM. If we're able to, we can adopt managed instances, which is a managed version of that for us. And if that is if we could do that successfully, then we can look at adopting Azure SQL databases. So those are the 3 options we've covered so far. Other options that are available, what we also want to cover is reserved instances. So in adopting those particular technologies, we've got reserved instances and reserved capacity. Can I get a show of hands of how many of you are aware of reserved instances and reserved capacity? Brilliant. So for those of you that are not aware, reserved instances and reserved capacity allow you to commit up front for a year or 3 years and achieve up to 72% saving depending on the technologies that you're utilizing. So for virtual machines, if you were spinning up SQL Server in a VM and you were literally doing that lift and shift approach, you can actually opt in for reserved instances for the compute, which is the actual virtual machine computation. You can, if you wanted to change that later down the line, change to a different flexibility model. So you can opt into other sizes in the same family of VMs and achieve flexibility and still achieve a saving moving forwards. You can also then pay for the software ahead of time, and that includes the operating system, but it also includes the SQL Server license on top of that, so you can commit to that upfront as well and achieve a saving. With reserved capacity, that allows us to translate the same saving and upfront commitment to Azure SQL databases. And with Azure SQL databases, the vCore model is currently covered. So that's generation 4 and generation 5. What you technically do is you opt in for virtual cores, so you pay for those virtual cores upfront. You pay for those ahead of time, obviously, with the saving, and then any additional cores you pay for on an ad hoc basis, on a monthly basis that you provision afterwards. That supports Gen 4, Gen 5, single databases, elastic pools, general purpose, and business critical tiers as well. So that gives you a lot of flexibility to adopt these reserved instances and reserved capacity. So we've also got other options available. So we've got Azure Tables. Azure Tables are NoSQL table stores in the storage account in Azure. We've got Cosmos DB. So for non-relational SQL databases, we can use Cosmos DB, and we can use Cosmos DB in conjunction with some of our relational databases that we already use, and so we can look to adopt that in conjunction. We've got Postgres, so we've got Azure databases. We've got Azure databases for Postgres SQL, which comes with over 83% compatibility with conventional Postgres SQL database, and we've got the same for Azure databases for MySQL. So if you're already utilizing Postgres SQL or MySQL, you can actually utilize that in the form of platform services already available on the platform for us. Other types of storage that I want to quickly cover is Azure Storage accounts. So Azure Storage accounts come with blob storage, table storage, file storage, and queues. So quickly, blob storage basically come in the form of page blobs or block blobs, depending on the type of data you're trying to store, whether that's big individual files or whether that's a lot of smaller individual files that you're looking to store, which are all accessible through a REST API, so you can access that directly from your solution. You've got file storage, and file storage behaves much more like your conventional network share. That's accessed through SMB, and it also supports services like Azure File Sync. So if you wanted to replicate your on-premise network shares onto the cloud securely, for example, for backups or disaster recovery, what you can actually do is leverage Azure File Sync to then sync your files across to Azure. Azure will also honor the same permissions that you currently have defined. So if you're accessing the Azure files through SMB, those permissions and the security you've defined on those files still translates across when you're accessing it from on-premise. Table storage we've already covered, and we've got queues. And queues is a way of basically queuing loads of messages across to different services. So it is accessible through authenticated HTTP and HTTPS requests, and it can deliver messages of size 64 kilobytes and under. It also has a 7-day retention. So if your messages cannot be delivered, those can be retained for up to 7 days until you can try and redeliver those messages across. Now, Azure File Storage is flexible, so it's constantly being developed, and more flexibility is constantly added to it. We're actually pushing the boundaries of the Azure Storage accounts all the time. So now in US and in Europe regions, we can now support storage accounts up to 2 petabytes in storage. Up until now, it's been 500 gigabytes, and 500 gigabytes still remains the limit for other regions such as the UK. But if you really needed to, you could push the Azure storage limit on the storage account up to 5 petabytes, based on a request to the support team to the support team. Now we support 20,000 IOPS, input and output operations per second. That can be extended to 50,000 IOPS based on request. We've got a limit of 10 gigabits per second ingress for non-US regions, because we're not in the US, but you can extend that to 50 gigabytes per second as well if you wanted to. The same goes for egress. Egress is currently limited to 50 gigabits per second in all regions across the globe. Now, there's no limits on the number of blob containers or anything in there, so you can store, theoretically, unlimited amount of blob containers, blobs, file shares, and files. You're not limited. You're only limited based on, of course, your IOPS performance and the size of the overall container. So you can be very flexible, and it easily works with other tools. So you can use things like AZ Copy, RoboCopy, Azure Storage Explorer, etc., and even APIs that we have configured natively for all of those storage accounts. So you can integrate with storage accounts very easily to store data very effectively and cost effectively as well, because essentially what you're paying for is, again, what you consume. You're not paying for an entire container, you're not paying for an entire drive, you're only paying for the storage that you're consuming in the storage account. Now, identity is something I wanted to talk to you a little bit about. I'm not going to have the chance to demo this again because I overran a little bit. So fair enough, you've provisioned all of this storage on the Azure platform, but you've got this team of developers, and this team of developers needs to code that solution to integrate with those technologies out there. How do you securely configure your connection strings in your solutions? How do you securely do that? Now, it may be that in your current development teams, you've got spreadsheets which are password protected, that a number of users have access to, that they can leave openly displayed on their screen somewhere in the CAF when developing remotely. Or maybe that you have more secure ways of sharing that data across through KeePass, but that still doesn't change the fact that those developers need to at some point have knowledge of what those usernames, passwords and connection strings look like. So what we've got is we've got services available on the Azure platform to allow us to do that. So services like web apps, services like functions, which we've already talked about throughout today's sessions, those integrate with what we call managed identity. What that essentially allows me to do, so I cannot demo it straight away, but what it allows me to do is it allows me to configure, I've actually got an example, I'll just very quickly show you this example. It allows me to give the application access to securely stored values in Key Vault without me personally having access as the developer. So if I look at this particular events resource group, then what you can see is that I've got an app configured in here. This particular app, what it's actually doing, although I can't show you, I've got the source code if anybody is interested and approaches me afterwards, is it's essentially pulling out a value from Key Vault. If it works. And the way that I've done that quickly, so this is a secret stored in my Key Vault. I can show you what the code looks like, but this particular secret, if I show you, is currently stored in this particular Key Vault here. And if I show you the secret as somebody that's got access to it, I can't actually show you the secret because the secret is a secret. So no, I can't show secret value. There we go. Preparation test text. So I can show you that little. That's been pulled through. And the way I've done that quickly is basically in my application, it's a single tick box that I've configured. No more than that. And that single tick box boils down to this little identity piece here. So by ticking. If it loads. By ticking the status to on, what this has actually done is it's registered the application much like a user would be registered or an object is registered in my Active Directory, which I can then use just like any other user to delegate access to other resources. And what I've done in this particular case is I have created an access policy on my Key Vault, and that particular access policy has been configured to give this particular web application access to get and list the secrets I have in my Key Vault. And as simple as that, I can then incorporate a couple of libraries, it's quite literally two, in my web app, and I can then off the bat just pull base key identity from Key Vault. And that's it. Thank you for attending.